here in Excel once again. And I think this will be our last time for a while. So let's see what we've done. If you recall, we did a strong acid, strong base, looking at the separate regions. We did a strong acid, strong base using just one set of formula for the entire thing. It looks like I did some extra points there, but if you remember, we had the if statements, and so we realized that the benefit here was you can make changes to the parameters of the problem, and the whole thing adjusts without having to take into account like where the different regions are in the equivalence point. And then we got to the weak acid, strong base, and it was even more complicated. We had 4 regions, and at any point, if you were to change the parameters of the problem, where those region cutoffs would be in terms of volume would change, right? And so then in the last video, we just derived a more like universal and applicable way to solve this problem using charge balance, right? And so now let's use those equations and that formula, to recreate this here, except instead of using the regions, we're going to use the charge balance equations. Okay, so let's copy this stuff. We'll paste it. We're going to call this charge balance. Okay, and let me make this a little bit bigger. Okay, so remember that this is CB, and we're going to just rename these with the new notation, right? VA and CA, and then we have KA, and we have CB. All right, and if you recall that now pH is our input. And from pH we can figure out the concentration of H+, and then from the concentration of H+, we can get the concentration of OH-, and from H+ and Ka we can get alpha, and then finally VB, right, which is kind of what we want. So we're doing this backwards, right, from the way we did it before. Our approach is different. Here we thought about adding volume, what happens to the pH. Now we're thinking about, given the pH, what volume was added. So let's just pick something in the middle just to try it out. So let's say a pH of 6. So it should be somewhere between 3 and 4 milliliters. You see that, right? If we had a pH of 6, it's somewhere between 3 and 4. So let's play around with our formula here. So this is going to be our input. And I actually want that to have two decimals. Just because that's how we like to do pH. So then H+ is 10 to the negative pH. OH- would be Kw divided by H+. So we're gonna reference that a couple times. So I'll put it down here. 1E minus 14. So OH- is Kw divided by H+. And I'm gonna go back in here. Hopefully I won't make any mistakes this time. And we get OH, and then alpha. Remember, alpha is equal to Ka divided by H+ plus Ka. And I'm going to go back here and put my dollar signs so that when I slide down, that stays on Ka. Okay, and then VB. This is the complicated one, but it's really not so bad because we've already put these values here, and everything else is over here in A and B. So the only thing you have to be careful about is making sure you have your parentheses correct and all that. It takes some practice writing equations and formula on a computer. If you've had any programming or computer science stuff, you've done some of this, and we've done quite a bit already together. So you will be getting better at it as you go along. You'll be able to see things. Okay, so if we look at, you should have it written down in front of you somewhere. So VA should be here, and I'm going to keep that at VA times alpha right here times CA. I'm going to put a $sign, and then minus H plus OH minus, parentheses. Now divide by parentheses CB, the $sign, plus H plus minus OH minus, close parentheses. And that should equal VB in milliliters, right? Do I have any mistakes? Let's see. Okay, I'm going to change the notation here from scientific to number. And it's 3.49 milliliters. And if you remember, we said we expected it to be between 3 and 4. So it seems like it's working. That's cool. So you go through the work once, and now this is actually even simpler. There's really only 4 columns here. If you remember, we derived this differently than the textbook does, and so hold on, I don't have it in front of me. Let me find it. Figure 1010 shows their spreadsheet, and they have the additional factor of phi and stuff in there. Ours is pretty simple. Now, remember, pH is the input, and volume is the output. So you could, if we change the pH to 3, we get a negative volume. So that doesn't make sense. You could play around with this and see, like, where does 0 start? If you're having a new problem, we already know that when you have 0 added, the pH is 3.98. So if we wanted to, we could start with 3.98. But to make this more universal, we can go with 3. Let's see. Let's just try it like this first. So we know we're going to want to probably fill in, but this gives us an idea of what it looks like and if we have any mistakes. And we have a mistake. Dang it. Every time, don't I? What's the mistake? Oh, I think I just went too far. Oh yeah, pH of 16. I forgot that I was. We'll go to. Yeah, we just went too far. There we go. Now it works. So there's only a certain pH range that is even allowed. So here it is. And the numbers seem to make sense. So let's go back in and fill it in with the numbers that we actually want. So at 3.98, we get 0. and then 4, 5, 6. The pKa is a point that we might be interested in, 2.67. Right, that's the midpoint here. pKa is halfway to the equivalence point, the equivalence volume. We'll keep going with 7, 8, 9, and then 9.27. What is it? 9.25. Yeah, we know 9.25 happens to be a important point as well. And we'll go 10, 11, 12. That's good enough. Okay, ready to make a plot. And so we're going to do this the same as we normally would, except remember we want volume as the x-axis and pH as the y-axis. And if we set it up just like we normally would, we highlight both columns, insert chart, it kind of works left to right. It's going to think that we want pH to be here on the x. And so we need to switch this. So we can go to select data. And here you can see the data chart, the data range is these two columns. But we want to switch the x values from those. We want that to actually be these two. We want the y values to be column D, pH. And we can adjust this. Yeah, we can change those things later. Right? And we can add labels and things like that. So now, if you look closely, I need to change this title to pH, right? And let's take a look at what we had here. So we want to basically see if it compares to this. So we're going to go VB x-axis from 0 to 16. And the pH on the y-axis from 3 to 12. Okay. And it is indeed the same. We don't have quite as much precision as the one I have here, but we could definitely, let's see, add. We can always add more if we wanted to, like interpolate between the points and such like that. Oh, I should put a title here. And going to, again, chart, add chart element under chart design. This would be pH. And there it is. Okay, so now we have the nice benefit here. Actually, you know what? I'm gonna go ahead and change. Just give ourselves a little bit more. Probably just drag this down. And these as well. Okay, and then I want to go to chart format. No, chart design. drag this down. Okay, there it is. That looks pretty good. And yeah, that looks really nice. So now, right, the benefit is, just like before when we did the logic, we can adjust the parameters of the problem and the whole thing adjusts and it corrects itself. So if we change the initial volume of the acid to 40 from 50, everything fixes itself and adjusts. Okay, so you can play around with this, changing some of these. And if you remember last time I asked you, one of the post-lecture questions was basically what's the answer if you change these to different numbers. And if you have the plot already, it's just a matter of plugging it in and seeing what happens. Okay. So look out for a question like that. That would be expected. So, okay, there it is. We're all done with this. Bye.